We are back in AP Calculus. It's a Friday. Today's date is Friday, September 20th, and it's kind of that cool date where if you write it out, 9/20, it's 2019. 20, what is going on with my, doesn't want to write right there. Okay, whatever, it's 2019. It's so weird that it doesn't want to write right there.
That is super weird.
Maybe if I scroll up and down again, it'll let me write right there. I don't know. Okay, well, it's 2019. So today we're doing the objective. Who's reading that?
I got it.
Go.
Never mind.
Use the differentiability test to determine if a function is differentiable at a system.
Yeah. So before we begin, the differentiability test is a add-on on the continuity test. So you have to have continuity test down. So that's why I'm reviewing it first. And then on top of that, you're also going to do if it's differentiable. All right. So continuity test. Flashcard. Go. What is it?
Draw with the
Three things.
holes, gaps, and
So those are the things that will make it discontinuous, and I totally agreed. Good job. But what is the continuity test? There's three things that need to be set equal to each other.
Equal the x,
height, left,
the height and
left, right.
Yeah.
Left, right.
Height, left, right.
Okay.
Height, left, right. So let's write it all out. There's three things that need to be set equal to each other. We have to say that the...
We should put. I have a question. I have a suggestion actually.
Yeah.
We should play left right because this is song.
We should play...
Left right. That's a song. That's a song.
I'll look into it and see if it's still appropriate. The left needs to be equal to the right, which needs to be equal to the height. This is the continuity test. And because which two of these are the same? Is it the left and the right are the same? The right and the height are the same? According to this piecewise function, which two of these are actually the same function?
Bottom.
The right and the height.
The right and the height, because it's saying to the right of this and at the height, because it's an equal sign. So these two are technically the same equation, so I'm just kind of going to turn them into one equation. So I'm going to do left is equal to right slash height. So let's go ahead and set them equal to each other. So 4x, yeah, salud. 4x minus 1 now needs to be set equal to x squared plus 2. What do I do after I set them equal to each other? You should be using the word suspect point somewhere in your answer.
Yes.
There it is. X turns into the suspect point. We are substituting 2 because that is our suspect point. Again, if you forgot that word, you can write it all out. Suspect point. We are substituting in our suspect point 2 into the value of x and see if the left and right are equal to each other. If the left and the right, and therefore the height, are equal to each other, it passes the continuity test, and therefore it is continuous at that suspect point.
It's wrong.
It's wrong?
They're not equal to each other.
Then it's not continuous. There it is, done. It's a gap. So we can say here, oh, you're already ahead of me. This is going to be 4 times the quantity of 2 minus 1 needs to be equal to 2 squared plus 2. I'm going to do it in a different color so it pops out, 2 and 2. And then finally when I do that, I get 8 minus 1 is equal to 4 plus 2, and therefore 7 is equal to 6. And then we want to write out fail. Fails continuity test. If it fails, that implies that the function is discontinuous. Therefore, we'll say f of x is discontinuous at x is equal to 2. It might be discontinuous other places, but we can tell that this function is 4x minus 1. That's a linear function. That's continuous everywhere. X squared plus 2, that's just a parabola, a quadratic. That's continuous everywhere. It's a polynomial. You don't have any weird fractions with variables in the denominator. Those are continuous everywhere. So we know that this function is continuous everywhere except for 2. So
It would be continuous if the suspect point would be 1.
if it was 1, would it be okay? Oh, if it was 1, it would be continuous. Yeah, nice. Let's come down here to the differentiability test. So now we're adding on. It's the same function. Look, it's just copy paste it. Same function. What we're doing now is this whole unit is about taking the derivative. We're taking the derivative of a piecewise function, which is easy. You just take the derivative of the top, write it out. Take the derivative of the bottom, write it out. Same suspect point, same inequalities. Let's go. Help me. I want to write it out. F prime of x is equal to curly brace.
These things are the worst.
You'll get really good at curly braces.
Remember we had the same discussion my freshman year?
You said. Well, anyway.
Yeah.
I mean, you will eventually, hopefully.
I
let's-
very much remember these being torturous.
Let's take the derivative of the top. Someone shout it out.
4.
4. Because it's x to the power of 1. 1 comes down. 1 times 4 is 4. X goes to the power of 0. Anything to the power of 0 is 1. So that's why there's no more x. X turned into a 1.
I was about to say 0, but no.
So it's going to say 4 for values of x less than 2, or to the left of the suspect point. And then we need to take the derivative of the right half, or the bottom part of the
2.
piecewise function.
2x.
2x for
X. The height of X and as
yeah, x is greater than or equal to 2 for the piecewise function. We're taking the derivative. And then again, it's left equals right equals height. It's the same thing, but now using the derivative.
We close
Wait,
the
but now I'm
bracket.
confused because like for it to be differentiable, doesn't it have to be continuous?
This is a good point.
Yeah, so the answer here is it's not differentiable, and you're kind of getting ahead of me. While it does pass the differentiability test, it doesn't pass the continuity test, therefore it's not differentiable, even though it passed the differentiability test. Differentiability test is kind of doing both tests in one.
So if you do the whatever test, continuous test, and doesn't pass it.
It's automatically not differentiable.
Okay.
Yes.
So
But so even on the homework, if it doesn't pass the continuity test, practice using the differentiability test just to get used to it.
So we should do both.
In practice, you don't need to do both tests. If it fails the first one, you're done. It's not differentiable. But let's practice. Maybe I should change my notes so that it's 1, so it is continuous, and then it doesn't pass this one, because maybe this is confusing you. But the definition of differentiability is it has to be continuous, and it can't have sharp corners, and it can't have any vertical tangents, and it can't have any. What are we missing? No, that's it. It's just those 3 things. Since it's not continuous, it's automatically not differentiable. I want to show you the differentiability test, though. So here we go. It's kind of pointless at this point. I agree. So, no, you're right. It's a good discussion to have. And it makes me want to think about redoing my notes. Left needs to be equal to the right, which needs to be equal to the... Okay, it's not height. What does this word change to? Slope. And I didn't write it out officially, and maybe I should. Can we write it officially over here in the top? Left, that is our way of saying the left, but we need to say it officially. We have to say that the limit as x approaches 2 from the left, like that, of f of x. Because on the free response for the AP test, they need you to prove it. You can't just say left. They don't know what you're talking about. You need to say the limit as x approaches 2 from the negative side, or from the left of f of x, needs to be equal to the limit of f of x as x approaches 2 from the right, needs to be equal to, how do I say height again? No limit.
It's just
Just f of
X.
2.
2. There it is. That's how you say it formally. But what you're really doing is left equals right equals height. So how do I say this formally? I'll write it directly underneath, which is what I should have done up here. I'm going to write it directly underneath. How do I say that? It's again going to be the limit.
The limit as x approaches 2 from the negative.
Yep, of,
What? Of fx.
not f of x,
Yeah, f of x.
not f of x,
F prime.
f prime of x this time.
Whatever. Nice. Okay.
So it's basically the same thing. This needs to be equal to,
Equals to the limit as x approaches 2 positive prime.
prime of x,
Prime.
needs to be equal to
The
f prime of 2. There it is. It's basically the same thing. It's just extra work. And then now we actually need to do it. So let's set them equal to each other. The right and the slope are the same thing because we have the greater than or equal to. So when I write out this problem, I'm going to get 4 is equal to 2x, and then I need to plug in my suspect point, and then I get 4 is equal to 2 times the quantity of 2. 4 equals 4. Done. 4 equals 4. But I still give me, so it, well, if you want to write this note, again, it's kind of being pedantic, but it might be useful for your notes. You can say, passes the differentiability test, but because it failed continuity test, not differentiable. I hope you're okay with me abbreviating differentiable and continuity because they're hard to say and they're hard to spell and it takes forever.
So, for this equation, you can take the derivative.
Just take the derivative, left equals right equals height.
Just do that.
Okay. Now there's the hard version. And this wasn't on the notes last year, so, I mean, it is in the homework, but I did want to add this to the notes just so that we would have it.
Wait, what was the
Oh my gosh, the bell.
Okay.
What are you doing?
Okay. The hard version that they always put on an AP test is making you solve an equation after you apply the continuity and differentiability test. So, because you know that we need to be differentiable everywhere, you might as well just take the derivative right now. Let's do it. Let's take the derivative. So it's going to be f prime of x is going to be equal to, practice your piecewise, whoop, whoop. It is a. Good job, Gio. A for x is less than negative 1.
Is it a plus b prime? No.
So b is a number, like 7.
Because yeah, okay, fine. Yeah, fine.
We're assuming that a and b are some constants. What about this bottom? What is that going to be?
2bx.
2bx for x is greater than or equal to negative 1. So we're going to have a system of linear equations, which means that we're going to have one equation for the continuity test, one equation for the differentiability test. So let's go ahead and make sure that our work is nice and neat. And I'm going to say over here, this is going to be the continuity test.
So to make it both continuous and differentiable, you have to check both of them, right?
Yes.
Okay.
Yes, exactly. So continuity test. We're only dealing with f of x. I'm doing left equals right equals height, which means I'm doing this thing equal to this thing. Let's set them equal to each other and plug in negative 1 at the same time. So I'm going to get a of negative 1, a times negative 1, plus b should be set equal to b times negative 1 quantity squared minus 1. I'm going to pause right there. Make sure that you understand what we're doing. Continuity test. This should be review. And let's solve. Give yourself room on the right-hand side. On the right-hand side, I'm going to do the differentiability test. That will be my other set of equations. So give yourself room, but know that we're going to continue with the continuity test, which is kind of a pun, or I don't know what you would say it. Let's solve. I have negative a plus b is equal to b minus 1. Stop me if you need time to think. I'm going to give you 5 seconds.
Wait. Oh, yeah.
Wait, so doesn't that mean a is equal to 1?
It does mean a is equal to 1.
Oh yeah, because you're in subtraction. Okay.
I'm going to subtract b from both sides. I now get negative a is equal to negative 1.
Isn't negative 1 squared 1?
It is, yeah. And what's 1 times b?
But don't you subtract the 1 with the other one?
So order of operations, you do multiplication right here before subtraction. Good question, good question.
Wait, so can you divide right there by negative a and that will equal?
You can't divide by negative a because we don't know what a is. What if a was 0? You'd be dividing by 0. You'd be committing a sin, a math sin. You can't divide by a variable unless they have told you explicitly that it's not 0.
I'm fine with that.
I'm going to multiply both sides by negative 1, multiply both sides by negative 1, and I get a, oh, I shouldn't be using green. I should be using a different color, whatever. A is equal to 1. I'm going to change those colors to black. Paint it black. A is equal to 1. I'm not going to box it because it's not the final answer. Well, I guess it's part of the final answer. And then using the differentiability test, I should be able to theoretically solve for b. Let's try it. So differentiability test means I'm setting a to equal to, a is set equal to 2 times b times negative 1. But we know what a is. A is 1. A is 1. This is going to be equal to negative 2b, which means b is set equal to negative 1/2.
What about, was there a negative applied to the a? For some reason I have negative a equals negative 2b. No, because there's no x. Never mind, you're right. Okay.
You got it? All right. So we solved for a and b. That's what we wanted. And that would probably be a multiple choice question.
That's it?
That's it. Again, the question was asking, find the value of the variables a and b. We found the value of the variables such that this is continuous and differentiable everywhere. If A is equal to 1 and B is equal to -1/2, it will make sure that you pass the continuity test, and it will make sure that you pass the differentiability test.
So that they pass.
They pass now because we found those letters. It's not a question of whether they pass, it's make sure they pass by getting the variables correct. We've got the variables correct so that they pass.
Okay.
Questions? Good luck on the homework.